Okay, so it's recording now. Okay, so we'll just, no big deal. Let's go through this quickly. Okay, so again, metallic elements, they're metallic. They're magnetic because all of the spins of the electrons are oriented in the same way. Non-magnetic elements are not magnetic because the magnetic domains are not aligned. So they just point in all directions. So they just basically cancel each other out. It's like this one's canceled out by this one. This one's canceled out by this one. So it doesn't matter, right? Okay. Ferromagnetism. So go ahead and write down what ferromagnetism is. And while you're doing that, I'm going to set up a little demonstration. Anybody want to read this? Okay, go ahead. Kimberly, read that for us.
Phenomenon where objects placed in a strong magnetic field become magnetized due to the poles from the atoms aligning all E minus in the same direction.
Yes, very good, very good. All E minus, that's electrons, some for electrons, so very good. So let's ask this question. So right now, in this neodymium bar magnet, the electrons are like this, right? They're all aligned in the same direction. Okay, they're all aligned in the same direction. Thus, we have a magnet. Okay? But what about in this metal washer? They're not right now. We can prove it because if we take two of these metal washers, they don't connect. Exactly right. They're not attracted or repelled. So basically, their electrons are like this. They're all over the place. They're oriented all over the place. But watch what happens. I don't know if we might be able to get this on camera. So I'm going to take four of them, and put them in my hand like this. I'm going to take this magnet and stick it to one of them. And then all of a sudden, I think, yeah, I might be able to make them magnetic. So that's what can happen, right? Is this magnet has a strong enough magnetic field to reorient the spins of the electrons in this metal to make them like this. So they're all pointing in the same direction. They're pointing in the same direction this magnet is, right? And so you can make it magnetic and be able to pick up something like that, which is, oh, we lost it. But it's pretty cool. Pretty cool. So, oh, we can almost get it back. Come on. We got it. Oh, there we go. So, where that went. But that's an example of ferromagnetism. That's an example of ferromagnetism. We induced a magnetic field in something that didn't have a magnetic field to start with. Cool. So this is how non-magnetic elements like iron, cobalt, nickel can become attracted to magnets, like that neodymium magnet. Okay, guys, this is called the, on this slide, what I want you to get off of this slide is something called the right-hand rule. I'm going to do my best to make this make sense. All right, so say we have this piece of copper wire. Yes, ma'am?
Tracy Smith needs to come to the office for just a minute, please.
Yes, ma'am. So say you have this piece of copper wire, all right? So I'm holding this piece of copper wire in my hand, and say there's an electric current going through the wire, okay? And it's hooked up to a battery, okay? And what we know, it says moving electric charge current can produce a magnetic field. This is called an electromagnet, basically, Okay? So by the right hand rule, what you can always know is the way your thumb points when you do your right hand out like this is always going to be the direction of the current. And if you roll your fingers in, that's always going to be the direction of the magnetic field. And so the current's going like this, and the magnetic field's going like this around the current. And so that's why it's always the right hand rule. And so the magnetic field generates a counterclockwise circles around the direction of the moving electrons. And this is a counterclockwise motion. That clock goes like this. Well, the magnetic field goes like this. So the right hand rule, if you say, hey, what way is the current going? What's going like this? What way is the magnetic field going? It's going like this. Okay? Right hand rule. That can help you with that. So that's really this slide. What you want to get out of this slide is which way is the current going? Which way is the magnetic field going? Right hand rule will tell you that. Okay. The stronger the current, the stronger the magnetic field can be produced. And guys, we could do this if I had it. I don't have it set up, but we can do this tomorrow when there's some wire in there, and you can wrap it around a nail and take some batteries and hook it up, and you can make that nail magnetic. You turn the nail into a magnet. You can pick little pieces of metal up with it. So, and if y'all seen this before, you've ever seen like at a junkyard where you have the big machine that goes along and like picks up a car with a big magnet. That's a big giant electromagnet, right? Because they cut it on and off, right? They pick it up and they cut it off and it drops it. It would stink if it was a magnet like this. You'd pick the car up and never be able to drop it. You know, it would just stay on. Yeah, you have to pull it off. That'd be hard. Big giant neodymium magnet. It isn't coming off. Actually, it's not going to come off. That would be so strong. That would be insane. Okay. So again, there's not. You don't have to write every word on this slide. Mainly, if you could describe the right hand rule, and you want to put counterclockwise, that'll be good. Cool. Can we just make sure you get that like I said, the electrons, moving current, moving charge or current can produce a magnetic field, and the direction of the field generates counterclockwise circles around the direction of the moving electrons. So if you could describe that using the right hand rule, you could do that, or you could just write all that's up here, I suppose. But remember, this is all in Google Classroom, and it's going to be on YouTube, so you don't have to. You don't get everything right now. It's okay. Okay, let's go ahead and go to the next one. So this is what I was talking about, guys, and we're almost done. Just go ahead. Go ahead and write the definition of an electromagnet, and that's really all you got to write here, guys. And is this the last one? Okay, yeah, this is the last one. So we are done after this. So like we said, if you were to take this and this screwdriver here, and you could take this metal wire and wrap it quickly around this screwdriver and hook this up to a battery, you could turn this thing into a magnet. You could turn this screwdriver into a magnet, because what we just learned, right, is a current going through a wire generates a magnetic field. Okay? Electric current, and so you have the current going this way, and I have my field going this way. And so if you generate a magnetic field, you can push or pull something. That's an electromagnet. And so here, what this is saying, you got your battery, a wire wrapped around there, and you'd have your electromagnet. Pretty cool. But if the current stops, the magnet stops. Whereas this, like a neodymium magnet, it's a magnet. It's forever. I suppose. I don't think its magnetism will ever go away. As far as I know. We'll do that tomorrow. We'll try to turn that into a magnet. I'm gonna go back, guys. I just was seeing. Okay, there may not be any places for you guys. Is there any place for you to write this stuff? Okay, don't worry. Let's just talk it through then. we'll just talk this last part through. So again, that's the electromagnet, a temporary magnet made by placing a piece of iron inside a current carrying coil of wire. So it's just a wire hooked up to a battery. And then, guys, it says the more loops of wire, the stronger the magnetic field. The stronger the current, the stronger the magnetic field. And so the more times I wrap this around this nail, the longer the wire, the stronger this magnet's going to be. So I can put more loops, stronger magnet, or I can get a bigger battery, and it'll be a stronger magnet. Okay. Real world magnets, electric motors. Guys, this is a big deal. You guys know Tesla and other automakers around the world are making a lot of electric cars. It's getting to be a big deal. It's, almost, I don't know if it's the wave of the future, but it's definitely a wave in the future. So it's kind of a big deal, these electric motors. So it's a device that uses an electromagnet to convert electrical energy into mechanical energy. And we have that right here in our kit. This is basically amp that up a whole lot, and you got your little electric motor for a car. And a generator. A generator is a device that uses an electromagnet to convert mechanical energy into electrical energy. So electromagnets in the real world. Okay, so electric motors, generators, and then I think lastly we have practice time. So you can just talking this stuff through. All right, so we will stop there, and then we'll go to our binder and that practice.